Hi students, today in your workbooks we're going to talk about representing contexts with equations. So basically they're going to give you situations and we're going to represent those situations with equations. So just as a refresher, let's look at a few of these equations here, and we don't want to solve them. We just want to say, is the solution going to be positive or negative, just as a refresher. The first one is a negative 8.7 times a positive 4. Well, we know that a negative times a positive equals a negative, so this one will be negative. This one is negative 8.7 times b equals a positive negative 1.4. So again, we have a negative and a positive. So when we have a positive, so to solve this, we would have to divide by -7. So we have a positive divided by a negative is going to be a negative. So this one will be negative. Here we have a negative 8.7 and we're adding a number that's going to give us a negative 1.4. So if we look at this again, we know that in order for negative 8.7 to end up a negative smaller number, we must end up with a positive larger number. So when we add and subtract positive and negatives, we have to take the difference. So if we have a difference that's smaller than what's in our problem, we know that this has to be a larger, it has to be a positive number that's smaller than the 8.7. And then finally, negative 8.7, and we're subtracting a number, and we're going to end up with a negative 1.4. So if this number is a positive number, we're going to add the opposite, which would make it negative. So we know that this number has to be a negative number so that when we add the opposite, we're adding a positive number to get us to a smaller negative number. So I hope that was a good review for you. We're going to move on to the second section of our lesson, and it's called warmer or colder than before. So they're giving us a bank of equations that they've got several equations here, and they all use the variable v, and we have to figure out which equations go with each situation. So they want us to do several things. So for each of these numbers 1 through 5, they want us to find 2 equations that could represent the situation. And they say some won't be used, so we can't just cross them off and say, okay, we haven't used these, this must be it. Then they want us to explain what the variable represents in the situation. And finally, they want us to determine the value of the variable. So let's see what we've got here. The first one says that between 6 a.m. and noon, the temperature rose 12 degrees Fahrenheit to 4 degrees Fahrenheit. So basically, we have a temperature that is going up. It's rising 12 degrees, and it ends up at 4 degrees. Okay, so it's rising to 12, and it's ending up at 4. So we need to see something added to 12 equals 4. So if we look at all of these equations, something adding to 12 equals 4. Let's see. Oh, here it is. This one. Okay, so I have v plus 12 equals 4. So that's one of our equations. Now we need to find a different equation because they said to find 2 equations. So we need to see what equation manipulates this equation to be something different. Remember our family of equations. So it could be something like 4 minus 12 equals v. It could be 4 minus v equals 12. It could be 12 plus v equals 4. So we need to look for something like that. So basically, let's look at the equations that have a 4 and a v in them. We already used this one. How about v equals 4 plus 12? Is that in anything we did here? It is not, so that's not going to work. Let's keep looking. Here's a 4 plus a negative 12. Do we have anything like that? We have a 4 minus 12. Well, subtraction is adding the opposite. So really, this equation will work. So we have v equals 4 plus negative 12, and that one will work. So here's one of the equations. Here's the other equation, and I kind of wrote these in here just as jotting notes down. So we have our two equations. Next, we have to explain, what does the variable v represent in this situation? Well, it says that between 6 a.m. and noon, the temperature rose 12 degrees Fahrenheit to 4 degrees Fahrenheit. So in this case, v is going to equal the temperature at the beginning, or the temperature at 6 a.m. Okay, so we have the temperature at 6 a.m., it's rising 12, and it's finally going to get to 4 degrees. And then finally they say determine the value. So if we determine the value, I've got v plus 12 equals 4. So to get rid of everything that's with my variable, I'm going to subtract 12, and I'm going to have v equals, I've got 4 minus 12. Well, this is like adding the opposite, and the difference between 4 and 12 is 8. 12 has the larger absolute value, so the sign is going to take that one, which is going to be negative. So v equals negative 8. So at 6 a.m., it was negative 8 degrees, and it rose 12 degrees. Negative 8 plus 12 is indeed 4 degrees. So this was the other answer. We went ahead and did all of the steps. So let's do number 2. At midnight, the temperature was negative 6 degrees. By 4 a.m., the temperature had fallen to a negative 16 degrees. So basically, we are starting with negative 6 degrees. I'm going to move over here a little bit. We're starting at negative 6 degrees. And at 4 a.m., the temperature had fallen. So that means we're going to subtract a number, and we're going to end up at negative 16 degrees. So this is kind of what we're looking at. Temperature was negative 6. That's where I got the negative 6. The temperature has fallen, so there's my subtraction. We don't know by how much, but we know it ends up at negative 16. So let's take a look and see what we have. Do we have any equations with a negative 6 and a negative 16? That's what we're looking for. So what is this one? A negative 6 plus v equals negative 16. Well, could this be a plus a variable? Well, remember, subtraction is adding the opposite. So what if my variable turned out to be a negative number? So this one could really work. So we've got negative 6 plus v equals negative 16. That's one equation. So now we need to look at another one that would be similar, but the numbers would be moved around. And the other one that I see that could work with all of these would be this negative 16 plus 6. Excuse me. So if I get the v by itself, that means I would have to add 6 to both sides. Adding 6 to both sides would end up looking like this one. So the second equation is v equals negative 16 plus 6. So I found my two equations. Now I need to state, what does the variable mean? Well, in this case, v equals the change in temperature. At midnight, the temperature was negative 6. It ended up changing, and it ended up at negative 16. We don't know by how much, and that's what the variable is telling us. So the v here indicates the change in temperature. So that's all you would write down for that. And then finally, they ask us to solve. So I'm going to use this equation to solve. When I add two numbers with opposite signs, I take the difference. The difference between 16 and 6 is 10. So I know I've got 10. Is it positive or negative? Well, the absolute value of 16 is larger than 6, so I need to keep that sign, which is going to be negative. So V equals negative 10. So the change in temperature was a negative 10 degrees. Number 3 says that the temperature is 0 degrees at midnight and it's dropping 3 degrees every hour, per hour. The temperature is negative 6 degrees at a certain time. So we start with 0 degrees. We're subtracting 3 degrees times every hour. And then at a certain time, the temperature is negative 6. So this is what we're looking for in our bank of equations. And it looks like the one that we're going to do is this negative 3 times V equals negative 6. So their equations, it's negative 3V equals negative 6. Then we need another one that's going to mean the same thing. So they move numbers around, but it's going to mean the same thing. Well, what do we know here about this negative 3V? What if we were to get V by itself? To get V by itself, we have to get rid of the 3. To get rid of the 3, we can do one of two things. We can divide both sides by 3, or we can multiply by the multiplicative inverse. So when we divide by 3, dividing by 3 is the same as multiplying times 1/3. It's the multiplicative inverse. So I can also use the equation V equals negative 1/3 times negative 6. That is the same thing as this equation. It's going to give us the same answer. So I've got two equations. What does V mean in this situation? Well, it's dropping 3 degrees per hour. So V equals the number of hours that it's going to take. And let's see, finally we need to solve it. So if I multiply negative 3 times negative 6, this is like negative 6 over 1. I can cross cancel. 3 goes into itself once. 3 goes into 6 2 times. Negative times a negative is a positive. So V equals 2 hours. The next one is the temperature is 0 degrees at, oh, did I do that in the wrong one? Oh, I did not. Okay, so now we're doing 9 degrees. So the temperature is 0 degrees at midnight, dropping 3 degrees every hour. So again, I have 0, dropping 3 degrees every hour, and the temperature is 9 degrees at a certain time. So we're going to look for something similar as what we just did, only now we're talking 9 degrees versus negative 6 degrees. So we know that we can look for negative 3V equals 9. If they have that, negative 3V, oh, here it is. So we've got negative 3V equals 9. That's one of them. And then we also know we can use the multiplicative inverse, which is going to be this one. V equals negative 1/3 times 9. There are our two equations. Again, they want to know what does V represent? Well, V represents the change in time. The change in time. Okay, so we have a certain amount of time when this temperature changes, and we need to know what that time change is. Is it going to be a later time or an earlier time? So to solve this, I can take this negative 1/3 and multiply it by 9/1, cross cancel, 3 goes into itself once, 3 goes into 9 3 times, a -1 times a 3, so V equals a -3. So that means we've got a -3 hours. So the change in temperature was 3 hours in the past. Number 5, finally, we have the temperature at 9 p.m. is 1/3 the temperature at midnight. So we need to look for something like 1/3 times a variable, okay? So let's look at what we have. 1/3, well, we have a change in temperature. It could be this one, change in temperature of a -4 and 1/3 times the variable. So we're going to use that one. And again, we're using it because we're not given a whole lot of information, but this equation is something that hasn't been used. We use this one, we use this one. So the ones that with the 1/3 that we've already used for the other ones, the other situations, so we can't reuse them. The next equation we're going to look for is something along the lines of this, but we're going to use the multiplicative inverse. So let's get V by itself. To do that, I would multiply both sides by 3. So I would have -4 times 3 equals V. And do they have something like that? -4 times 3 equals V. Oh, there it is. -4 times 3 equals V. So that's the second equation we're going to use. And then they want to know, what does V stand for in this situation? Well, V in this situation would be our temperature at midnight, because they don't tell us that. Sorry, I'm running too close to the edge of my writing pad there. This is midnight. And then finally, they want us to solve it. Well, -4 times 3 is a -12 equals V, so it's -12 degrees at midnight. So that's how we're going to use signed numbers in situations that have an unknown amount or variable. All right, I think I'm done on this page. Let me minimize this and we'll go down to my second page, which is 16.3 in your books, and it's called Animals Changing Altitudes. So I know this is one of Josh's favorites, where he can dispute the authenticity of our situations by the types of animals that are in the same environment. Mrs. Goldwyn would be so proud, but for math purposes, we're going to pretend they all live happily together. And number 1, they want us to match each situation with a diagram. So they have A through F situations, and then they have lots of diagrams here, and I believe that's all on one page of your workbook. So let's start with A. It says a penguin is standing 3 feet above the sea level and then dives down 10 feet. What is the depth? Well, starts at 3 feet. Let's look at A. A, they're starting at 3, and then it's going down, but did it go down 10? Well, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It does. So this is A. I'm going to go back up to part A and put that it is number 1. I'm going to match them on both ends. All right, part B says a dolphin is swimming 3 feet below the sea level and jumps up 10 feet. So we've got 3 feet below, and we're starting at 3 feet below, and we're jumping up. So we need to find something that starts 3 feet below. Here, this starts 3 feet, but it's above. So we've got 3 feet below, And it looks like there's a 10, but we need to see something jumping up, so it's going to go the opposite way. 4 is 3 feet below, and it goes up. So does it go up 10? Let's check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It does. So this is going to be situation B. And that's graph 4. So I'm going to go back up here and put that is number 4. Part C says a sea turtle is swimming 3 feet below sea level and then dives down 10 feet. So we're starting 3 feet below and we're diving down 10. So we have to look for those 3 feet below again. Here's a 3 feet, but it's above. Here's a 3 feet below, but it ends up at 10. It's not diving down 10. Let me reread our situation. Yes, it says it dives down 10 feet. This one doesn't dive down 10 feet. It dives down to 10. So let's keep going. This one starts at -3 and it dives down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number 5 would be situation C. Starts at -3, dives down another 10 feet. So 5, part C is 5. I'll write that here. D, an eagle is flying 10 feet above and then dives down to 3 feet. So 10 feet above and dives down to 3. Well, here's a 10 feet above and it ends up at 3. So we just don't have that arrow from here. Whoops, that's a funky looking arrow going to 3. So this, number 2, would be situation D. And I'm going to go up here and put that it's number 2. A pelican is flying 10 feet above and dives down, reaching 3 feet below. So he's not diving down 3 feet. He's diving down to reach 3 feet below. So let's start with 10 feet above. This one is not starting out at 10 feet above. This one starts out at 10 feet above, ends up at 3 feet below. So this would be our graph, and I'm just going to finish that other arrow, if I can connect it all, to 3 feet below. So this number 6 is E, and I will go ahead and put number 6 on E up here. And then it looks like we only have one left, but let's check it to make sure that it does match. A shark is swimming 10 feet below sea level and then swims up, reaching 3 feet below. So we're starting at 10, or he's swimming at 10, and he swims up to reach 3 feet below. So it looks like it would be this one. He starts at 10, he swims up, but he stops at 3 feet below. So again, number 3 would be F. And by F, I'm going to put a number 3. All right, I'm done with that page. So I'm going to go on to my next page, but I am going to need those situations for the second part. So I'll keep my notes that I have printed out by me for that. Because number 2 says they want us to write an equation to represent each animal's situation and then answer the question. And they want us to be prepared to explain our reasoning, which we can show with the math. So A said, I'm just going to reread it again. It says, a penguin is standing 3 feet above. So we're going to start with 3 feet above. And he dives down 10 feet. So that's minus 10. What is his depth? And that equals his depth. I'm going to use D for depth. Well, to solve this, we know that subtraction is adding the opposite. The opposite of 10 is a -10. And we know that to add two numbers with opposite signs, we take the difference. So I'm going to say D equals, the difference is 7, but we need to figure out, is it a positive 7 or a -7? And I take the absolute value of these two numbers, and 10 has the larger absolute value, so my answer is going to be negative. So his depth where he ended up was at -7. Part B is the dolphin. A dolphin is swimming at 3 feet below sea level, so -3. And he, let's see, what does it say? He jumps 10 feet, so that means he's going up 10. And what is his height at the top of the jump? Okay, and that's going to equal the height. So I have -3 plus 10. Again, I'm adding two numbers with opposite signs. So I take the difference. So the height equals 7. Is it a positive or negative? The absolute value of 3 and 10. 10 would have the larger absolute value, which is positive, so it's positive. So he ends up at 7 feet above sea level. Part C is a sea turtle. He is swimming 3 feet below sea level. So I'm going to put my 3 feet below sea level. And let's see. And then he dives down 10. And they want to know what is his depth. That will equal his depth. So again, subtraction is adding the opposite. So I can add the opposite of 10 is -10. And that will equal his depth. Well, I have two numbers that I'm adding together and they have the same sign. So I just add 3 plus 10 is 13. And I know that they keep the same sign, and that will be -13 equals his depth. The eagle is flying 10 feet above sea level. So we're going to start with a +10. He dives down to 3 feet above. So he dives down to an unknown amount, by an unknown amount, and he ends up at 3 feet above sea level. So this is a trickier one. He starts at 10, he dives down, so we know we need to subtract, but he dives down an unknown amount, and then he ends up at 3. So to solve this, I can use my family of equations, and I can say, well, I know I can do 3 minus 10 will equal, be careful on this though, because the sign in front of the number stays with the sign. So 3 minus 10 won't equal C. 3 minus 10 will equal -C. So let's do this. We've got adding the opposite. And when we add the opposite, we take the difference. So the difference between 3 and 10 is 7. We know it has to be a -7 because the absolute value of -10 is larger. So -7 equals -C, but I want to know what C equals. So basically, if I have -7 and a negative equals a -C, I can divide by -1 both sides to get rid of that negative. And I'm going to get 7 equals C. Okay, and let's see if that makes sense. We're going to read the situation again in D. An eagle is flying 10 feet above sea level. He dives down by 7, and does he end up at 3? And yes, he does. So let's try the pelican. The pelican is flying 10 feet above the sea level, and he dives down, reaching 3 feet below. So again, he dives down an unknown amount, but this time he dives down 3 feet below sea level. What is the change in altitude? So I'm going to do the same thing, only instead of ending with a +3, I end up with a -3. So I know I can do that again. -3 minus 10 will equal a -C. And again, adding the opposite. Now I have two numbers that I'm adding together that have the same sign. So I know that -13 equals -C. But I don't want a -C, so I can divide by -1, and I'm going to get a +13 equals C. So basically, the pelican is diving down 13 feet, and he's going to end up at -3. F says a shark is swimming 10 feet below the sea level. So we're going to use a -10. and he swims up, reaching 3 feet below sea level. So he swims up an unknown amount and he reaches 3 feet below sea level. What is the change in depth? Well, again, we're going to just repeat the process. I have -3. I'm going to subtract a -10, and I'm going to get C. Now, this time C is positive because the sign in front of C is positive. So I've got -3 minus a -10. Subtraction is adding the opposite. Now I have two numbers that I'm adding together that have opposite signs, so I know I need to take the difference. The difference between 3 and 10 is 7, and 10 has the larger absolute value, so my answer is going to be positive. So 7 equals C. And again, the shark is swimming at -10 below. He goes up 7 feet, which would he would end up at -3. So that, my friends, is section 3. We're going to go on to section 4. And we're not going to do all of these on this video. I'm going to make this a little smaller so we can see all the words. There it goes. We're just going to do the first one, and then I'm going to have you choose one to do on your own. Sorry, I'm trying to get it so we can see all of the words. There we go. Okay. So we're being asked to do several things. We're given 8 different situations, and we're being asked for each situation. They want us to write an equation, tell what the variable and each term in the equation represent, how the operations in the equation represent the relationships, how we use inverses, and the solution. So we're going to break all of this down for the first one. And then I want you guys to choose one more to do. You can choose whichever one you'd like, but I need you to show me all of the steps. So the first one says, as a 7/4 inch candle burns down, its height decreases 3/4 of an inch for every hour. How many hours does it take the candle to burn completely? Well, let's take a look. The first thing we need to do is write an equation that represents that situation. And the equation would be, we have a 7¼ inch candle, and it's burning down. That means it's going down, so we're going to subtract. How much is it decreasing? Well, it's decreasing 3/4 of an inch every hour. So it's going to decrease 3/4 times every hour. And we want to know how many hours does it take. So that equals something we don't know, right? Or 0. This is going to tell us when it burns down completely. So there's our equation. Next, they want what does your variable in each term represent? So our variable is H, and that represents the number of hours it will take to burn. Number of hours to burn. Okay. The 7¼ represents the candle at the beginning. Candle at the beginning. I'm kind of abbreviating. And the 3/4 times H represents how much it decreases, the amount of decrease. Okay, so we just did the second part. The third part is how the operations in each equation represent the relationship in the story. Well, the operations we're using are subtraction. So subtraction represents, I'm going to say equals the decrease. Right? So that's one operation we're using. We're also using multiplication. So multiplication, okay, and the multiplication is here, 3/4 times an hour. So multiplication represents the amount of time or the amount of decrease per hour. Okay, so we've got a subtraction symbol and we've got multiplication going on here. Then they want us to know, how do we use inverses to solve the unknown quantity? Well, we need to solve the unknown quantity before we can show that. So I'm going to move up here and I'm going to rewrite my equation. So I have 7 1/4 minus 3/4 of an hour equals 0. So the first thing I need to do is try to get rid of everything that's with my h. And the first thing I'm going to get rid of is anything that's being added to or subtracted from my h. So I'm going to get rid of this. So I'm going to use the additive inverse, 7 1/4 subtracted by itself. So that's an additive inverse. You guys may have not heard this in a while, that term, additive inverse. And so what I have left over when I subtract that is negative 3/4 of an hour equals negative 7 1/4. So 0 minus 7 1/4 is negative 7 1/4. The next inverse I'm going to use is the multiplicative inverse of this negative 3/4. And you guys know that as a reciprocal. So I'm going to multiply by the opposite, which is negative 4/3. And this is going to be multiplied by negative 4/3. And this is actually called the reciprocal or the multiplicative inverse. And when I do that, 4 cancels out 4, 3 cancels out 3, negative cancels out negative, and I have an h by itself over here. But when I do that over here, I need to figure out, I got to change this negative 7 1/4 to an improper fraction. So 4 times 7 is 28, plus 1 is 29. So I have negative 29 over 4 times my negative 4 1/3. And when I multiply these together, 4 cancels out 4, negative cancels out negative, and I get 29/3. But they're asking us how many hours, so we don't really talk about hours in improper fractions. So I'm going to change this to hour language. And I know that 3 goes into 29 9 times, which is 27, and there are 2 left over. So it's going to be 9 2/3 hour. So we explained how we used inverses to solve the unknown quantity, and we came up with the solution to the equation. So there's a lot of steps for that one particular situation. Again, I want you guys to choose one problem, number 2 through 8, choose one, and do that work to come up with an answer, doing all the steps, and then I will check that in class when you come back to class. Lastly, we just have a quick summary. So I'm not going to read the whole summary. You guys can read it yourself. But basically, what the summary of the lesson is that we know we can use variables and equations involving sign numbers. Sign numbers are positive or negative numbers to represent a story or a situation and to find out the answers to the questions that they're asking. And then again, they gave you 2 more examples here, but that's basically the summary of our lesson. You guys have practice problems to do as well, and I will see you in class next time.